Good evening. My name is Samantha Morris, and today I'll be discussing my optimization project. This project focused on how adjusting reaction time and solvents used for recovery affect the yield, purity, and recovery of acridone synthesized from a nucleophilic aromatic substitution reaction, which you can see right here in this reaction scheme. This is the synthesis that I was working with. You can see that the starting material undergoes nucleophilic aromatic substitution under strongly basic and high temperature conditions to form the acridone product. This reaction is well documented in the literature, so my goal was to explore whether these changes in time and also in solvent used could optimize the reaction under our lab's constraints. In the original synthesis that we used as a reference point, we'll call that our week 0 synthesis point. That was one of my group members' original products that was the most pure out of the 3 members of our group. We obtained a moderate yield and moderate purity along with a pretty low recovery that week, so we really wanted to focus on optimizing those parts. Our week 0 reaction only ran for 1.5 hours compared to a 6-hour reaction time in our literature that gave about a 95% yield compared to our 64% yield in week 0, which is obviously quite a bit lower. That raised the question of whether the shortened reaction time was limiting our yield or purity. So we decided to increase that for this test. The literature also recommended using acetone and diethyl ether as wash solvents. So in addition to modifying the reaction time, we also tested whether using cold acetone or ether washes during the recovery step would improve the purity without dissolving the product. Here's a summary of the conditions I used. The week 0 control, which was our original synthesis, ran for 1.5 hours at 180 degrees Celsius with 4 milliliters of KOH and 4 milliliters of DMF. To extend the time while staying within the allowed conditions due to the constraints of our lab, I ran 2 modified reactions in week 1 and week 2. Week 1, I ran the reaction for 3 hours compared to that original 1.5. And week 2, I also ran that reaction for 3 hours just due to time constraints, but used a pure starting material, hoping to remove any variability that could cause issues to truly test that time. My hope was to see if doubling that reaction time could increase the yield or the purity, and whether a cleaner starting material helped. Now, before we performed the recovery for the reaction, we did a solubility test using all of the solvents that you can see here. We have cold acetone, diethyl ether, warm acetone, a combination of ether and cold acetone, and then ether and warm acetone. We were looking for a solvent that produced a pale yellow and a fine powder for the least amount of dissolving and the best purity. And as you can see here, that ether and cold acetates, the 4th one down, that one looked like it had definitely the best, so we chose that originally. This also was going to help us predict whether using those solvents during washing would lose us risking product due to any solubility. You can kind of see in the warm acetone, it was pretty soluble, and so we wanted to avoid solvents like that. Now for my results. First of all, for the solubility test, after running the reactions, we tested that recovery using that cold acetone and diethyl ether. Our week 0 with the original diethyl ether solvent, we saw a 59% recovery of the product, which we had originally thought was pretty low. However, that week 1, I only recovered 38% of my product using that cold acetone and diethyl ether, and week 2, I only recovered 14%. Therefore, it did not improve the recovery, it actually worsened it, and the acetone likely dissolved that product despite its lower temperature, which was to try and prevent that from happening. This is because the polarity of the acetone likely allowed more of that product to dissolve than expected, leading to those low recoveries. Now, when we're talking about yield of the reactions that I ran, the original reference point for week 0 was a 64% yield of the product, which was okay. Week 1, when I ran it for 3 hours with that less pure starting material, I had a 41% yield, and week 2, I had a 31% yield. Those were both worse and, in fact, did not optimize the synthesis. So we determined that time was not a deciding factor with low variation. Had we run that reaction for 6 to 12 hours, we may have seen a higher yield, but that's unable to be determined with only this 1.5 hour difference. Our variation in this experiment was not large enough to draw any conclusions. Now, my IR from week 2 was most definitely my best IR. You can see that there was still an OH peak there, but there was a nitrogen methyl peak, which does show that our product did form. That OH peak could be from any residual water. We did not let it dry yet for a week before taking that IR, so that could lead to that. But this does show that even though our yield was not as high as we would have liked, or our purity, which I'll get into in a minute, although those weren't as high as we liked, we still did get the product, so increasing the time still allowed us to do that. Then for the purity, here's my NMR from week 2 as well. This was also showed that our product was not nearly as pure as our original. You can see that the starting material possibly did not react further. You can see I've got those A, B, C, and D peaks labeled, and then the TMS peak. And the extra peaks could be from any side reactions or, again, that starting material. This supports the lower purity seen in week 1 and week 2 and suggests that the time alone was not any sort of limiting factor under the test conditions. To summarize, the optimization attempt was ultimately unsuccessful, and the results were contrary to our hypothesis that increasing the time and changing the solvent to cold acetone and diethyl ether would increase our yield, purity, and recovery. Increasing the reaction time from 1.5 to 3 hours did not improve our yield or purity, and the cold acetone and diethyl ether washes actually led to lower recoveries, likely because the product was dissolved into the wash solvents. Because the increase in time was small, we still cannot rule out improvements. At a 6-hour or 12-hour reaction time, those may improve, but those were outside of our experiment's constraints. Overall, the experiment shows that the solvent choice during recovery has a large impact, and that more significant time adjustments would be required to meaningfully compare that to the literature and our original week 0 synthesis. Here are all of my references and for my literature sources. Thank you so much, and have a wonderful night.